Good morning. I'm Annalisa Bianchera from the University of Parma, and I'm going to present this research work regarding the influence of material and capsule filling process with Minima on aerosolization performance by dry powder inhalers. The delivery of drugs to the lungs by dry powder inhalers is strongly influenced by the characteristics of formulation and by process parameters involved in capsule filling. Powder formulations for inhalation products commonly consist of a binary adhesive mixture between a coarse carrier, typically lactose, and the active principle that can be added even at very low dosage. Material attributes and filling process parameters may have a critical effect on dosage uniformity and on powder aerosolization performances. The aim of this work was to analyze on the material side the contribution of different types of lactose, and on process side, the effect of instrumental settings on dose uniformity and on aerosolization performances of powder mixtures. These powders were dosed in hard capsules through a bench capsule filler, Minima by IMA. To this purpose, the work was divided into 4 parts. The first one was devoted to the evaluation of encapsulation parameters on final capsule weight. Then, the role of different types of lactoses on aerosolization performances was assessed. To check the reliability of the capsule filler, 2 filling settings were compared, and finally, the effect of ball height was evaluated. All experiments were performed by filling hard gelatin capsules size 3 by means of Minima, a bench capsule filler designed to dose solid products in hard capsules. The filler can simulate the process and dosing of production machines. Among different dosators available, the one having a 2.5 mm diameter was chosen. Aerosolization performances were assessed by fast screening impactor, by discharging capsules from a medium resistance inhaler, RSO1 by Plastiape, and by applying a flow of 60 liters per minute. Emitted fraction and fine particle fraction were then calculated with respect to the amount of loaded powder. To evaluate the effect of encapsulation settings on final capsule weight, a 2-cubed full factorial design was set up by selecting as input parameters bed powder height, piston compression, and dosing chamber, and by selecting final average weight and relative standard deviations as outputs. Piston compression defines the length of slug reduction inside the dosator, while dosing volume is defined by piston diameter and chamber height. Height of piston compression and dosing chamber, expressed in millimeters, were set on minima in the configuration for dry powder inhalers. Final average weight and relative standard deviation were considered as outputs to build a regression model. Relative standard deviation was not affected by filling parameters, while all parameters, namely height of powder bed, piston compression, and dosing chamber, significantly affected final weight of the capsules. In particular, compression was the factor affecting it the most, as also evidenced by coefficient digits in the model. A further step of the work was focused on the evaluation of the role of material properties on aerosolization performances. The table shows the selected 4 raw materials for lactose deriving from different producers and having different particle size distributions. These lactoses were repeatedly sieved to retain the fraction above 38 micrometers. The remaining fraction below 3 micrometers was assessed by dynamic light scattering in order to detect the amount of remaining powder. These were used as coarse carrier for the preparation of adhesive mixtures with fine lactose having an average diameter of 3 micrometers, which was intended to simulate a generic micronized active principle at a concentration of 2, 5, or 10%. Evaluation of aerosolization performance by fast screening impactor evidenced that for emitted fraction, no significant differences could be ascribed to different types of lactose, independently on the type of dosage of fine. As for fine particle fraction, which was corrected for the amount of remaining fraction in the coarse carrier, a high variability was observed for all mixtures, independently on the type of lactose or on amount of fine fraction. Lactosphere MM50 was anyway the best performing one and was consistent as a coarse carrier at all concentration levels. For this reason, this was selected for further experiments. Two settings on minima were compared with a target dosage weight of 15 mg. In setting A, dosing was set at 20 mm and piston compression at 3 mm, while in setting B, dosing was set at 5 mm without compression. Taking into consideration the emitted fraction, no significant differences could be detected between filling setting A or B for mixtures containing 2 or 5% of fine fraction, while a significantly lower amount of powder was emitted for the mixture with 10% of fines filled with method B. No significant differences were observed on fine particle fraction due to high variability. Filling method A seemed on the whole to provide more consistent results. Finally, the effect of ball height on aerosolization performance was assessed. Minima can be equipped with different thicknesses below the sampling ball. By increasing the thickness below the ball, an increasing trend in emitted fraction was observed, while no specific pattern could be observed with respect to fine particle fraction. To sum up, minima was found to be reliable in terms of accuracy and repeatability even at very low dosages. Compression was identified as the main parameter affecting both final weight and emitted fraction after capsule discharging with RS01. Moreover, the type of raw material can dramatically affect the fine particle fraction, with Lactosphere MM50 showing better performances with 2% of fines. I would like to thank the Group of Advanced Drug Delivery of the University of Parma and EMA for providing the instrument. Thank you very much for your kind attention.